will walk you through the process of getting to the coverage plots, RNA sequence coverage plots in a genome browser from a specific locus or gene page. So what I'm going to do is I'm going to go to this default gene that's in my search button at the top. Once you get to the gene page, you'll notice that the gene page is made up of many different sections. You can either scroll down to go to the different sections, or you can click on any of the items in this menu. I want to go to the transcriptomics section because I'm interested in RNA sequence data. Once you click on this, you'll see the transcriptomics section right here with all of its sections collapsed. I will specifically open up the transcript expression section, and this will load up all the experiments that are available for this particular species and this particular locus. And so looking in here, you'll see that this particular one, the first one I'm looking at, is an RNA sequence experiment. It was published by Tonhake et al., and there's some more information about it here. And you can see the graph here of the FPKM values, and you can play around with this section a little bit. There's some additional graphs you can turn on here. But in this case, we're interested in looking at the coverage plots. So you'll notice here that there's a little option to look at coverage. So if I expand this section, this will open up a really small image of what the coverage plots look like in the genome browser. And so here you can quickly look at that. But if you want to look at this in more detail in the genome browser, you can click on View in Genome Browser. And what this does, it takes you to the genome browser to that specific location of the genome where this locus is, and it'll turn on a default track for this data set called a density plot. And this shows you all the samples from the experiment using this particular graphical method. So the darker it is, the more expression there is in that particular area. You can mouse over each section and it'll tell you which sample it is. But if you want to look at the coverage plots, what we can do is we can add additional tracks. And to do this, the easiest way probably is to search for the data set based on the author's name. So what I'm going to do is I'm going to click on the little arrow here about this track, and you'll see here's the author. So I'm just going to copy this into my clipboard so I can use it later on. So we can close this. And now I'm going to click on Select Tracks. Once you click on Select Tracks, you'll notice that there are hundreds of tracks. There are 1,224 tracks to be exact in this particular moment in time when I'm looking at this browser. If I type in the author's name, this will immediately filter the results, and now I'm looking at the experiment from this author. You'll see that there are 52 matching tracks. So an important thing to note is that this is made up of multiple different types of tracks, including unique and non-unique tracks. So there are 16 non-unique. You can see them right here on the left, and there are 16 unique. The non-unique track shows coverage for any reads that map to more than one location. And so this gives you an indication if there's a repeat gene, if it's part of a repeat family, or this gene includes multiple repetitive elements, you may see a lot of coverage in the non-unique plot. But typically, most people may be interested in looking at the unique tracks. And so I'm going to click on unique right now. So this will further filter my results based on the author to only showing me the tracks that are unique. And so I can look at this and I can say, well, I'm going to look at all of them. So I can select all. Once you select all, you'll notice in the background here that the tracks are already loaded. And so here they are. These are all the tracks for my gene of interest. The genome browser is very, very jumpy, and so it's often better to scroll with the scroll bar on the right here. But this is the gene of interest right here. This particular one happens to have 3 splice variants. And as you scroll down, you will see that there's coverage. The coverage is in red here because this is a strand-specific data set. So the red coverage is going from right to left, which is the orientation of this gene. You'll see this gene starts here on the right, and the arrow is pointing to the left side. You'll notice here there's a gene on the right side of this gene, the gene of interest, and this one is going in the opposite direction, so it's blue. And so if we move down to here, you'll see that the arrow is going from left to right. Okay, this is tutorial. Hopefully you found this tutorial useful. As usual, please click on the Contact Us link and ask us any additional questions.